Bismillahirrahmanirrahim. Allahumma salli ala Muhammadin wa ali Muhammad. Assalamu alaikum. This is the second video in the series which I just began recently about the making of what are called awfaq in Islamic occult sciences, or what are referred to in English as the so-called magic squares. And the first video I did was on the order 3 magic square, the so-called 3x3, or what's called in Arabic al-muthallath, al-wifq al-muthallath. And today I would like to examine that in more detail, and then I will introduce the 4x4, after which I will probably do another video going in more detail on the 4x4, and then I'll do the same in another video on the 5x5. The 4x4 is known as the al-wifq al-murabba, or the order 4 magic square, and the 5x5 or order 5 magic square is known as al-mukhammas. But as I said, today we want to look in more detail at the 3x3. So instead of using the whiteboard, we're going to use this technique here of writing on this brown shaded paper so we can avoid problems with glare and so forth. I got this technique, actually I copied this off of a guy who has a really good channel called Numberphile. It's a math channel and they use a similar method, and so I'm going to write with this Sharpie. Now I've already written down, I've already constructed the 4 magic squares which I introduced last time that are associated with the 3x3. So you can see that each of these squares has 3x3, and that means that there are 9 subsquares in each, and that in each of these 4 examples you have the numbers from 1 to 9, 1, 2, 3, 4, 5, 6, 7, 8, and 9 arranged such that every vertical column, every horizontal row, and every diagonal will sum to something called the magic constant in English, mathematical nomenclature, and in the case of the 3x3, that's 15. And then each of these squares is associated with one of the 4 elements, so we have fire, earth, air, and water. And you will notice then that the key point is that you are moving around the initial number. So when it's at the top, it's associated with fire. Now notice again, you have your corners, and then you've got these pieces which we may call the intermediate cells, and you have the center. So what happens is that when you make the earth square, all you do is you move the initial number, which in this case is 1, the smallest number, the minimum number, to the lowest position, and that gives you earth. The lowest, again, within the intermediate squares. It'll never be on an odd. And then with the air, it moves up here. And with the water square, the 1 or the minimum value is there. Also notice that in this basic form where you only have the numbers 1 through 9, the odd numbers are always in the intermediate position and in the center, of course. 5 never moves. And the evens are always occupying a corner position. Now you should look and convince yourself that that's true in each case. 1 is odd, so here we have 3. We have 7, 9, again 5 in the center. 1 is odd, 3, 7, 9, 5 in the center. 1, 3, 7, and 9, again 5 is in the center. And you notice in all of these that 2, 4, 6, and 8, 2, 4, 6, and 8, 2, 4, 6, and 8, 2, 4, 6, and 8 are always in the corner position. Now, that will not necessarily be the case when you actually try and encode something into one of these squares. So let's just stick with 1. We'll stick with the fire square. And you remember we did the divine name Allah, and that this is composed of alif and lam and ha, and alif is 1 and lam is 30 and ha is what was it, 5, or in English 1 30, 30, and 5. And if you add all those up, to you get 66. Sittin, right? And then the key here is that you take 12 and you subtract it from 66. 6 minus 2 is 4. 6 minus 1 is 5. 54. Then you divide 54 by 3. And the value you get, if you don't know, you put a 1 here. There's your 3. Take down the 2. Bring down the 4. Then what happens? Well, 3 goes into 24 how many times? It goes in 8 times. Then you're done. And so it's 18. And so the initial value will be 18. So we don't want to run out of space, so we'll just write small. So if we just make one down here, I'll show you how it's done. I did this in the last video, but this is just a review. And in case you haven't seen that one, do go and watch that one. Now, 18 then is our minimum value. So if we want to use the fire square, then our minimum value is here. It will go in the top cell, the top intermediate cell. So what we do is we follow the pattern, and we'll write an 18 here. And then where's our 2? We look here, it goes down here. This will be in this position, so we increase that by 1, 19. And then 3 is here, so we have 20. Then this will be 21, 22, 23. And then where's our, that was our 4, 5, 6. So where's our 7 position? It goes here, so 23, 24. And where's our 8 position? It's over here, so it'll be 25, and then this will be 26. So we have 18, 19, 20, 21, 22, 23, 24, 25, and 26. And if you check, each of those will add up to 66. So here you have 5 and 1 is 6, and then you have 3 2s, 66. So you have 8 and 2 is 10, plus 6 is 6, and then you carry a 1, so you have 2, 2, and 1 and 1, 66. 3 plus 4 is 7, 7 plus 9 is 16, carry the 1 again, you'll have 3 2, 66. If you go across, you'll get the same thing. 3 plus 8 is 11, plus 15, you're going to have a 6, you'll carry, and again, you'll have 66. 4 plus 2 is 6, then you have 3 2s, 66. 9 plus 6, 15, plus 1 is 16, so you have a 6, you'll carry the 1 again, you'll have 3 2s, 66. If you go diagonally, 19 plus 22 plus 25, let's just draw an arrow here. So 9 plus 2 is 11, plus 5 again is going to be 16, then you'll carry the 1 and you'll have 66 again. Let's do the last diagonal. 3 plus 2 is 5, plus 1 is 6, and then of course you're going to have 3 2s, 66. So it works. Now let's do another one, but let's do one where well, let's do an earth one. Let's say we have the divine name Basit. Notice I took the alif and lam off. Of course, it's al-Basit, but with the divine names, you typically drop the alif and lam. So what does that mean? Well, that means we have ba, and we have sin, and we have ta, and we have alif. So ba is going to be 2. Sin is kalima 60. Ta is 9 and then 1. And so what do you get? 272. 2 plus 60 plus 9 plus 1, 72. Now then you subtract off 12. In the 3 by 3, you always subtract 12. So 2 minus 2 is 0, 7 minus 1 is 60. Well, that's easy. 60 then divided by 3 is just 20. And then let's see how you would construct this one. Let's do a different one this time. Let's do earth. That means we start at the bottom. So it's 20, 21, 22, 23, 24, 25, 26, 27, and 28. Now, if you verify this, then this will be 3 plus 8 is 11, plus 1 is 2, right? So you have 11, so that's 12, then you carry that 2, 4, 6, 72. And you will get the same value for each. I'm not going to go through it. But now what happens each time we've had a situation where it was divisible by 3? What if it's not? So let's take the divine name Al-Jalil. Al-Jalil. So the alif and lam will be dropped off. So you have Jalil. So you're going to have Jim, and then you're going to have Lam, and then you're going to have Ya, and then you're going to have Lam, right? 1, 2, 3, 4. 1, 2, 3, 4. So what are the values? Jim is 3. Lam is 30. And we had 2 lambs. I should have written the 10 there. It doesn't matter. So if you add all those up, what do you get? You get 30 and 30 is 60, 70, 73. So our value here is 73. Now, we want to subtract 12. Remember, you always subtract 12. 3 minus 2 is 1. 7 minus 1 is 6. It's 61. Oh boy. This is a problem. 61, is it divisible by 3? No, it's not. We put a 20 here. We get a 60 here. And it's 20, remainder 1. So what do you do if you have a remainder? I'm going to give you a general rule, and I'll tell you what you do. If you have a remainder, when you're dividing by 3, then the remainder is either going to be 1. If the remainder is 1, then this implies that you add 1 in the 7th cell. And if it's a remainder of 2, this implies that you add 1 in the 4th cell. So let's do this one. We had Jalil. Let's construct our square. We're doing a 3 by 3. I don't know. We'll just go with Earth again. So, again, the value is 20. Remember, with Basit, it was also 20. So here we'll also start with 20. Now, if you want to keep track of actually what's going on, let's look at the Earth square. This is the first. We're going to write the numbers here in red. This is number 1. This is 2. We'll put them in the upper right-hand corner. Then this is 3. This will be 4, 5. That's a 3, 5, and then 6. And the 7th cell would be here. This is 8. And now we have 9. So the key thing is we have to remember that we had a remainder of 1. So we want to increase by 1 in the 7th cell. So this one is going to become important. Let's circle that from now. So how do we fill this in? We're using blue. So you start here. Remember, it was Al-Jalil. The minimum value is 20. It was remainder 1. So we have 20. And you just go in the same way. 21, 20, 21. So this is 1, 2. Then here would be 22. Now look in Al-Basit. The Basit square is the same. 20, 21, 22. And again, it'll be the same here. 23, 24, 25, until we come to the 7th. So what do you do in the 7th? You increase it by 1. So you go 25. It would be 26, but we're not going to do that. We're going to put 27 here. And becomes 27, 28, and then 29. Now this one, we really want to check this one. So let's go across. We have 9 and 1 is 10 plus 3 is 13. And remember, we want it to come out to 73. So we have a 3 and we carry 1. We've got 3 2's, which is 6 plus 1 is 73. So this one checks out. We're going across right now. So 2 plus 4 is 6. 6 and 7 is 13. Carry the 1. Again, 3 2's plus 1 is 73. Going across here, 8 plus 0 plus 5, that's also 13. Carry the 1 is 73. So check, check, check. Let's do the going down vertically. 3 plus 2 is 5. 5 plus 8 is 13. Carry the 1. Again, you got 3 2's. 6 plus 1, 7. That one checks. 9 plus 4 is 13. Again, you carry the 1. 3 2's is 6 plus 1 is 73. Check. 1 plus 7 is 8. 8 plus 5 is 13. And again, you'd carry the 1. 3 2's are 6 plus the 1 is 73. Brilliant. So far, so good. What happens here? 8 plus 4 is 12 plus 1 is 13. We carry the 1. It works. Now, what happens here? 3 plus 4 is 7. 7, so it checked here also. So 7, 3 plus 4 is 7, plus 5 is 12. Oh my God, what happens? It's 2. Carry the 1, and it's 72. So when you have a remainder, one of the diagonals, whenever you have a remainder of whether it's 1 or 2, in the 3 by 3, one of the diagonals is not going to work. It's mathematically, it can't happen. So this is how you deal with the remainder situation. Now I'm going to just leave that now. I think that's sufficient for the 3 by 3. And you should practice a few of these. What you really should do, I think, is get some graph paper. Graph paper is very useful. Get yourself some, drawing equipment, some rulers, some squares, these triangles as they're called. And if you're not good at arithmetic, get yourself a calculator. It's a very good calculator, the HP 35. They haven't paid me. Haven't got that many views yet, but at some stage, HP will be paying me. Okay, so this is the 3 by 3. Let's now maybe look at the 4 by 4. So here is our 4 by 4 magic square. This example that I'm going to give you is going to be of the fire element, and we'll look at the other ones perhaps on another occasion. Let's keep it simple. This is different from the 3 by 3 in that it doesn't have a central element. There's 1, 2, 3, 4, 1, 2, 3, 4. So there's a total of 16, 4 times 4 cells in this square. If you have an odd square like in the 3 by 3 square, which is an odd square, the central element, the value in the central cell times 3 will always be the magic constant. So for example, if we just look at one of these in our original piece of paper, this is 5. 5 times 3 is 15. And so in all of these, the magic constant was 15. Remember when we did the divine name Allah, what's the central value? It's 22. Times 3 is 66. With Al-Basit, it was 72. What's 24, which is the central element for Al-Basit, times 3? Well, it happens to be 72. 3 20s are 60, 3 4s are 12. 60 plus 12 is 72. If you look here, you had 24, and when you have a remainder 1, that relationship, doesn't hold. Because if you check, because of course it's not going to work because you have 73, which is not divisible by 3. So if you have 24, let's just take this times 3, you'll get 2. 4 times 3 is 12, carry the 1, 2 times 3 is 6, 72. And so this obviously does not equal 73. So when you have a remainder situation, that relationship doesn't hold. We don't have a convenient relationship like that for the 4 by 4. There are other relationships that hold for certain kinds of 4 by 4s, but I'm giving you the simplest one for now, which is simplest at least that's used in Islamic occult sciences. So this is the fire element, and the minimum here, which will be 1. So we have to go from 1 up to 16. And the magic constant will be 34. So 1, this is the minimum position. This is the number 1 position. And then you do a knight's move from chess. And then you get the 2. Now then, since you've come to the end, you can't do a knight's move and come here, so you put down the 3. Then you can't go this way, but maybe you can go this way. So you go this way and you do a knight's move, and you get a 4 here. But then you're stuck again, so you have to put the 5 next to it, and then you do a knight's move this way, and you get a 6. Well, you stuck here, so you've got to do the 7 diagonally off of the 6. Then the 8 will be, you can knight's move up here, so that will be the 8. Then 9 will be down here. 10 will be knight's move over here. Then you've got 11 up here. Excuse me. And 12 has to go over here. 13 is here. 14 is here. 15 is in the down corner position. And finally, you've got 16. Now, as I said, it's a 4 by 4. And it needs to add up to 16. But let's just double check here. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. This should be right. So if you just want to double check, if you go across right to left, it's 1, 14, 11, 8, 12, 7, 2, 13, 6, 9, 16, 3, 15, 4, 5, 10. Now we want to double check. All of these have to add up to 34. So let's add across. 8 plus 1 is 9, plus 4 is 13, plus 1 is 14. So we'll have a 4 in the ones place, and we've carried the 1, and we have a 1 and a 1 and a 2. So that's 34. That's correct. Check. 3 plus 2 is 5. Plus 7 is 12. Plus 2 is 14. Again, you carry the 1, and you will get a 34. Check. 3 plus 6 is 9. 9 plus 9 is 18. 18 plus 6, if you do 8 plus 6, then you'll have a 4. Again, you'll carry the, in this case, you would have been, yes, does that work? 3 plus 9, 9, 18. Yeah, you've carried a 2, so it's 34. Then here you have 5 plus 4 is 9. 9 plus 5 is 14. Again, you're carrying a 1. 1 and 1 is 2, plus the carried value is 34. So it works. How about this way? Well, here 1 and 2 is 3, plus 6 is 9, plus 5 is 14. Carry the 1, and you have 1, 2, 3. 34. Check. 4 plus 7 is 11. 11, that'll be 20. 24. Carry the 2. 2 plus 1 is 3. 34. Check. 1 plus 2 is 3, plus 6 is 9. 5, that's 14. Again, it comes out 14, so it's 34. 8 plus 3 is 11. 14, carry the 1, 1, 2, 3, 34. Check, check, and check. Okay, so let's do an example. Let's say we did the divine name As-Samad. Okay, again, you take off the alif and lam, so that leaves Samad, which comes out to Sad. And then we have Mim, and then we have Dal. So Sad is 90, Mim is 40, Dal is 4, or let's do this in English, 90 plus 40 would be 130, right? Plus 4, yes, is 134. Now, remember that with the 3 by 3, the number that you start with that you want to encode has to be reduced by something. There's a subtraction factor, and it was 12. 12. 12. Every time we reduced the number in question by 12. So here, what do you think the reduction factor will be? It's not 12. It is, in fact, 30. So the factor that you want to reduce is 30. So we've got 134 minus 30. That's simple enough. What's it going to be? It's going to be 104. So we come back up here and we have 104. And now what do we want to multiply that, divide that by? Do we divide by 3? No. Again, with the 3 by 3, everything is divided by 3. Here, because it's a 4 by 4, we're dividing by 4. So what is 104 divided by 4? Well, if you don't know, then you do it the long way, right? And so you realize that 4 goes into 10 2 times, and you'll get an 8. And then 10 minus 8 is 2, and then there'll be a 4. And then you realize that 4 goes into 24 how many times? 6 times. So the value, the quotient, excuse me, and there's no remainder, which is very good because we're not dealing with remainders today. So we want to put then Samad into a 4 by 4. So we know that our minimum value then, our smallest value, is going to be 26, and 26 will go in the 1 position. So what we'll do is we'll put 26 here. It'll be 26. Then in the 2 position, we'll put 27. Then in the 3 position, we'll 28, and so forth. So let's do that. We're running out of space here, but we'll squeeze it in. We'll write a little bit smaller. See if we can do this. 1, 2, 3 lines. 1, 2, whoops. 3 lines. That's not bad. It's a little lopsided, but so now again, you use this as a guide. So what you could do is you could put these little guides here. You could, like we did before, and put 1 here. Then our 2 would be here in this corner, 2. Then our 3 would be here, 1, 2, 3. Then 4, again, we come here, put our knight by the knight's move. 5 goes here. 6 would be up here. 7 would be here. 8 is this corner piece. 9 is down here below the 7. 9, right? Then knight's move, we got a 10 here. Then we got our 11 up here. Knight's move, our 12 is here. 13's got to go here. 14, 13, 14, yeah, 14 is here. 15 pops all the way down here, and then you got your 16. So let's see how we would do this. We need something to weight this down. I'll use this hard drive to weight it down. Now, so we had 26. So we go to the 1 position. So we put our 26 here. Where's our 2 position? It's here. So we go to 27. Our 3 position here is here, so we'll have 28. 1, 2, 3, and where's our 4 position? Aha, it's right here. 29, 30. Where's the 6? It's here. 31. 7 is here. 32. 8 is here. 33. 9 is here. 34. You got to keep track. 10 is here, so it'll be... no, that's 16. We're screwing... 10 is here. 34, so 35. 10, then 11 here. We'll have... this will be 36. 12 is here, so this will be 37. 37. 38. 14 is 39. And 15 will be 40. 41. Gosh, I hope this works. Okay, let's try now what happens. Do we want to do this, or do we want to do a calculator? I don't know. Let's see. 6 and 7 is 13. 13 plus 1 is 14. And what are we trying to get? 134. So there is a 4 here. And then 2 plus 3, that's 6, 8, 12. And we carried a 1. So yes, sure enough, it is 134. Let's do this one. 9 and 2 is 11. 11 plus 9 is going to be what? 20, which would be a 4. Carry the 2. 3, 6, 9. Plus 2 is for, 134. Correct. 6 plus 7 is 13. 13 plus 1 is 14. So we've got a 4. Carry the 1. 4 plus 2 is 6. Plus 4 is 10. Plus 3 is 13. 134. 3 plus 8. Okay, wait. Let's do it a different way. 8 plus 8 is 16. 16. Then you got another 8. That's 4. That's 24. So it'll be 3, 6, 9 plus 4 is 13. 134. So vertically, they all work. Check, 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 check. Let's change color. There's a blue one over here somewhere. Blue. Let's go across. We got to squeeze it in here. Gosh. 3 plus 6 is 9. 9 plus 9 is 18. 18 plus 6, that's going to be 14. Carry the 1. So it'll be 3, 6, 9, 10, 11. Is this not working? This is the point where maybe you need to have a calculator. 3 plus 6 is 9. 9 plus 9 is 18. 18 plus 6, yeah, that's 24. Yeah, so that works. So then you have 3, 6, 9, 10, 11, 12, 13. Yes, 134. It works. Golly. 8 plus 7 is 15. 15 plus 2, we've got 17. Then we've got 24. So we do have a 4. Then we have 3, 6, 9, 11, and 13 again. 1 plus 4 is 5. Plus 1 is 6. Plus 8, we've got your 14. Then we have 2 plus 4 is 6, 9, 10, 11, 12, 13. 134. يعني 5 9 14. Okay, so now that's 4 here, 3 6 9, 3 and 6, 10 11 12 13. 134. Correct. Doing the diagonals. 6 plus 2 is 8, plus 1 is 9, plus 5 is indeed 14, so we'll put a 4 here. And then we would have 3 plus 4 is 7, 10, 11, 12, and we carry to 1, so it's 134. Azim. 0 plus 4 is 4, 4 plus 7 is 11, 11 plus 3 is, again, it's going to be 14, right? 3 plus 7 is 10, yeah, 4. So we've carried to 1, 3 plus 2 is 5, plus 3 is 8, plus 4 is 12, and we carry to 1, so it's 13. And you see that we now have the divine name Samad encoded in the 4x4. So that is the example of a 4x4. So there is actually a general formula. So there is a general formula for magic squares. So that if we call the magic sum S, then S is equal to some initial value where you start the square times a number n plus beta, which is the skip constant, and then you have your n again divided by 2 times n, the quantity n squared minus 1. And of course, n is greater than or equal to 3. So you have a 3 by 3 square, right? You have a 4 by 4, you have 5 by 5, and basically you have an n by n square. So depending on the size of the square, that's the value that you put in. You can't have a 2 by 2 magic square, and you can't have a 1 by 1. So the lowest value you can have is a 3. The smallest magic square you can have is a square of order 3. Beta, this value is the skip constant. So when you had the 3 by 3, for example, or even in the 4 by 4, we had 1, 2, we had 1, 2, 3, 4, 5, 6, right? 7, 8, and 9. There's a difference of 1 each time. So that's the skip constant. And then A here is our minimum value. Okay? So if we have a 3 by 3, so in the case of, where's red? So if n equals 3, if n equals 3, that's our 3 by 3 square. So what does that give us? If n equals 3, we have s equals our minimum value, and let's say in every situation we're going to start at 1 to give the basic case. If n equals 3 and a equals 1, then the formula reduces to, this will be a 1, so you're just going to have n here. And the beta is 1 also, because you're skipping by 1. So you're going to have n over 2 times n squared minus 1. So we substituted in the a value and sorry, I forgot to write this in, beta value. And a equals 1 and beta equals 1. So now if we put in 3, we'll get s equals 3 plus 3 over 2 times 3 squared minus 1, which is 3 plus 3 over 2 times 9 minus 1, which is 3 plus 3 over 2. 9 minus 1 is 8. Cancel these. This will be 4. 4 times 3 is 12, and you'll have 3 plus 12. So this is the situation when n equals 3. And a is 1, and the skip is 1. So that's why we subtract 12. Now, if we now keep everything the same, but this time we say we let n equal 4, then we'll get s equals what? 4 plus 4 over 2 times 4 squared minus 1. right? We substituted a 4 in where we have n. We put a 4 here and a 4 here and a 4 here. So we have 4 plus 4 over 2 times 4 squared minus 1. So that becomes 4 plus 4 divided by 2 is 2 times 16 minus 1. What's 16 minus 1? It's 15. So it's 4 plus 2 times 15. And that becomes 4 plus 30. So this is 4. Right here we had n equals 3, or the 3 by 3 square, okay? Here we have n equals 4, or the 4 by 4 square. I'm going to do it for the 5 by 5, and that will conclude our video. So what's the formula for the 5 by 5? So let n equal 5. We've got to squeeze this in here. Then s will equal 5. We substitute here 5 where all the n's are. It'll be 5 plus 5 halves, or 5 divided by 2 times 5 squared minus 1. So it's 5 plus 5 over 2. 5 squared is 25 minus 1. Now we have 5 plus 5 over 2. 25 minus 1 is 24. So 24 divided by 2 is 12. So we have 5 plus 5 times 12, which means that s equals 5 plus 60. So this is the situation where we have n equals 5, or the 5 by 5 magic square. So you have to subtract 60 here, divide by 5. Here you would subtract 30 divided by 4. Here you would subtract 12 and divide by 3. And that is the general sort of procedure that you use with magic squares of order 3, 4, and 5, or الوفق المثلث والوفق المربع والوفق المخمس. والله أعلم.